Hello, my name is Bradley Wilkerson. I'm working on question 1. So the first thing that we want to do is figure out the genotypes of the parents. And the best way to do that is we find the 2 largest samples of the children from the parents. And so we have one parent. Well, the parents would be plus, so the wild type, which I'll just indicate by the plus. Then we have the agouti, and then we have the mahogany. And then we have the ragged wild type and then the other wild type. And that should be a reverse, which it is. And then we'll take the 2 of the less ones, the smallest amount, percentage is for the kids. We'll write that down as well. So we have the rugged, the agouti, and a wild type with a wild type, and mahogany, which are also inverses. And so when we look at this one compared to this one, we see that these 2 are flipped from this side, And so if we were to flip this, we would have the parent type. And so because we have this, we know that agouti is in the middle. And so we would have, it doesn't matter which way the order goes, but it'd be either rugged, agouti, mahogany, or it could be mahogany, agouti, rugged. So once we know that, what I like to do is I like to then circle the ones that that are changed from the parent type. And so these 2 are changed because those are what we just found out. And so if we were to do this one for the next 2, so we have wild type, 3 wild types. Then we have wild type, and rugged. So this one is different. And then to find the inverse of that one, we would need one that has all the recessive traits. So we have this one, which has rugged, agouti, mahogany. And then for the last one, we should just have these 2 as being different, which it should be wild type, agouti, but instead of mahogany, we have a wild type. And then for the next one, we have rugged, wild type. But instead of a wild type, we have mahogany. And so once we get those, then we can put it into our equation where we have the 2 middles. And then we can put these 2 first. I was like working on left to right. And so we have 16, 18. So we're going to add 16 and plus 18. And we're going to divide that all by the amount of people that are in, well, not people, the amount of offsprings that we have. And so we have 206 offspring when we add all the offspring up. So we divide it by 206. And when we do that, we get 17.48%. And this also is our distance between the alleles on the genetic trait. So from R to A, we have 17.48 mus. And to find the next one from A to M, we're going to be using the M with the middle agouti. So to do that, we have the 1 plus 1 plus 13 plus 12. And that's all over the 206. So that equals 13.11%. And so the distance between those two is 13.11. And so if we were to add both of these together, from R to M would be 30.59%, 30.59 mules from each other from the R to M. And then from the numbers that we had before, so we had the 17.48. I like to move it back to the decimal point where you have 1748. And then we times that by the 13%, so the 0.1311, and that equals 0.02290. And then once we have the 0.2290, you times it by how many offsprings we have again. 0.02290 times the 260, or 206. And then from that we got 4.717. And so that's what we hope to get out of this ratio. But when we take our two double crossover events, we only have two offsprings. So what we do is we do the 1 minus 2 over the expected, which is 4.717. And then from that we get 57.60%. And that is our inference value.